Till now we have used regression decision tree for classification purpose. Okay, but can we use this decision tree as a regression to build a regression model? So let's see it is possible or not. So till now we have used our decision tree as a classifier. Now we are interested to build our decision tree as a regressors, and it is possible for build a regression model. And it is possible. So let's see. So what are doing actually for splitting the data? So just remember in the what are doing in regression technique, we have actually parent data, and for we have finding the based features according to the information gain, which is the maximum information gain. Then according to their features we have splitting the data. If we have D, then we have splitting the data D1 and D2, and corresponding to the edge features supposedly. And similarly, this the same process is also doing for this node. Edge node, we are repeating this thing, and according to that we are building the decision tree. Suppose let's take we have a query point xq. Suppose let's take we have a query point xq, and we have to find its corresponding output level. Suppose let's take this query point. First we have to check here, then we have to check. Suppose let's take first we have checking here xq is like on this data set. Then suppose fulfill, yes, these conditions, actually this is conditions. Yes, xq fulfill these conditions. Now we have to check these conditions. These xq fulfill these conditions. Suppose yes, no, it's full not fulfilled. Then we have reaching this. Now here we have checking the number of classes, number of points according to the majority. Suppose let's take we have n1 positive points, n2 negative points. Suppose let's take, and according to the majority vote, and suppose let's take n1 is n2 greater than n2. Then here n2 is majority, then we can declare that our xq, then we can declare that our yq will be positive because of its majority vote. These things we are doing in for a classifications in decision tree. Okay, now let's see. So what, how to choose these features here? How to choose in a regression? Actually this splitting, we have done the splitting for a corresponding features, and how we will do these jobs by simple using here the informations gain technique. Here we are using the informations gain to build the classifier. Here we are using, but in regressors instead of using informations gain, here we are using the MAC, mean square errors technique. We are using the MAC or MAE, or another language called, it is called the median absolute deviation. So this thing is called the mean square error. This thing is called the median absolute error. Or median absolute deviation. Median absolute deviation, both are the same thing. Okay, just in regressions purpose we are using these two things. Here we are using for regression. So to build a regressions we are using these two things instead of informations. So let's see how we will doing this job. So here what are doing, we have to build a decision tree. Suppose let's take it's our D data set, and here we have some OIIs for this data set. The output labels we have. First what we have to do, first we have to do the mean of this mean, or if we just interest to take on the median absolute error, then we have to find the median. Suppose let's take in this example I am using the mean square error. So if we use the mean square error, then for this data set corresponding yi, we have to calculate its mean value. Means actually we are interested to find the class regressor. If we are regression, then data sets, our data sets will be look like this. Here yi, this is our xi features vector, this side is our features vector. Here yi is not a single 0 or 1, it's a not a 0 or 1, that will see in classification. It's not. Here our yi is a real number, means 1.2, 1, 2.58, 3.9, something like that. Okay, here yi is simple, means our real number. Here yi is a simple real number here. So now we have to find the mean of its real number. We have to find its mean of the yi's for this data set. Suppose let's take, it's called our yi hat. This mean we have got. Okay, means average mean, that is means average mean, average of yi's. Okay, that thing. Now we have to choose the which features actually we have to choose here, divide it. So that's depend on the that's depend on to find the our mean square error. Mean square error we have to. So how to find this mean square error here? Let's see. So we have to find the mean square error. First we have to find the deviations. Square error means we have here for each data set we have yi. We have to first subtract this data set and taking it square. Means square, first we have to take the error yi minus yi here, this is the error, then we have taken its square. Okay, then we have taken its mean, I is equals to 1 to n. If we have not, if the stack of d equals to n, then this one we have divided by. Okay, this is simple, the formula of the mean square error. Mean this 1 by n, this mean, then we have taken square, then this thing is error, mean square error. Because of this thing is called the, because this formula is called the mean square. Okay, I think now we have to calculate a mean square error. Now similarly for that we have to calculate it for each mean square error. Because of this mean square error we have find for one features. Just see this thing, this mean square error we have find for one features, and also there have various features also. There are features 1, features 2, there are various features. Features 1, features 2, features 3. So let's take, we have k features. So for each features we have to find this mean square error. Suppose let's take features 1, we have find the mean square error MAC1 for features 1, MAC2 for features 2, MAC3 for features 3, MACK means square error k for features k. Now we have to choose the minimum mean square error to find the entropy, to find it's the right features. So we have to find the minimum of, MACs, minimum of. Then according to this we have to split it. Suppose let's take this minimum value is, suppose let's take this minimum value is fm. Okay, let's take. So according to this minimum features fm, we have now splitting this data en. Suppose let's take, after splitting we have reached here d1 d2. Okay, first let's take first here we have to choose. I think I have doing some mistake here. This is nothing. First how to choose, let's see. Suppose let's take, first we have taken here one f1. Suppose let's take, I am doing some mistake, sorry, my bad. So suppose first let's take, I am choosing here first features 1 I am choosing here. Okay, first I am choosing features 1. By using features 1, simply I am splitting this thing by d1 and d2 by simply using features 1. That also previously we have seen. By simply using features 1 we have divided this thing. Now after using this here, we have similarly we have calculated here the mean value. For this one we also calculated its mean value. For this D1, here also we have calculated its mean value. For the D2, but it is mean actually. Mean value for the D2 we have we will calculate it. For this D1 we will calculate its mean value, and so for D2 we will calculate its p value. Then we will calculate its weighted MSE. Weighted, it will be the same thing is we are doing for weighted entropy. So we can easily find its here weight value. Here also we can find its weight value. Now you will find its weighted MSE. Weighted MSE for D1 data plus weighted MSE for D2. Just sum of these. Just we have calculated sum. Just if you just visualize this thing internally, then you can easily think this thing is same as entropy, and this thing is same as the weighted entropy. Then just both the same thing, but both the for just entropy we are using for classifications, and for regressions we are using here mean square error, and similarly for at the end of the day we have seen that for calculate the informations gain we have subtract the entropy of the D set minus entropy of the weighted entropy. We have subtract this thing. So to find the information gain value. Okay, that we will see for calculated the informations. The same things also happening here. So for features 1, so for as the place of informations gain for features 1, we are calculating this value. Okay, we are calculating the MSE for the data set D, for this data set D, minus we have using the weighted MSE for the data set D1 plus weighted MSE for the data set D2. We will calculate this thing. Okay, this thing is calculated for, first we have calculated for features 1. This thing is first calculated for features 1 by using this thing. First we have using the features 1, then splitting the data, then after splitting the data we have calculated this value for features 1. Similarly for features 2 we calculated, for features 3 we calculated the same thing, repeating this thing. After that for features k we calculated this thing. Suppose let's take its value is, suppose let's take we are calling it ei we call e1. Now this value we call e2, this value we call e3, this value we call e4, ek. Now all the ek's we have to find the minimum. So to find the minimum of all the ek's, suppose let's take our em. Suppose let's take it's our em. Now the final decision tree will be made based on this em, based on these features fm. Okay, so the final decision tree we will make, the final decision tree that we will make D, D1, D2, that we will make from these features fm, that will splitting. This is the final one. First we have to consider for each features. Okay, first we have to consider first features, then we have splitting this, then we have calculated this MSE, and after that calculated the MSE, then subtracted from the weighted MSE, then we calculated the error. The same things also calculated for each features also. So after that we are finding the minimum of the edge error value, and according to these features we will finding the final decision tree. Okay, these things we have to do in for regressions. That means the simple thing is that the entropy we have using in classifier, build the classifier, the same MAC here we are using for build the regressors. Because of that, our in regressors our yi value is a real number, but in classification our yi value is a class level in simple type of integers. Okay, this is because of this we are using simple mean square error MAC, or it is depend on the situations, means we have taken mean square error, or we have taken here median absolute error or median absolute deviation. That's depend on our situation. Now if you just conclude this lecture, so in classification we have taken to find the best features, we are to find using the we have reduced the entropy value. We have reduced the entropy value towards 0 to finding the best features. For regressor, to finding the best features, here we will reduce the MAC value, mean square error value, towards 0. And if MAC is 0, this means what? Our data is, if we will see this thing, if H is entropy is equals to 0, then we called it is a pure node. Just remind this thing. Similarly, for if our MAC is equals to 0 for regressions, we call it is a pure node. Means in this node we have no mistakes. This thing means that. Okay, the both are the same thing, but visualization is from different angle. Application is from different angle, but both are the actually same thing. Okay, and for median, just same thing also will happen here. For median absolute we have taken the median, for mean we have taken the mean, nothing else, both the same thing. Now I think it will be better if we just take an example how actually look like a decision tree for a regressions. We will see this thing in classifications. So classifications we will see this thing look like this one. If we have this one F1, this one is F2, then it's look like this kind of figures, this kind of. Okay, this kind of look. But what will be actually look like in regressions? So let's see. Okay, let's see how actually decision tree regressions look like. Let's see. So this is the look like this kind of decision tree. Just I am taken this is an image from Google image. If you search it on Google decision tree regression, you can easily first image you can easily get this one. I'm just picking from the Google image. Okay, so the decision tree regressions is look like, just see this thing. This data is our actual data. Our actual regressors is for this data, this one. Okay, this is the actual regression line. Just see the blue line, my blue line. Okay, this is the actual regression line. But if we use the decision tree, first we have taken the maximum depth too. We will see in previous lecture, if we decrease the depth, then we are going to underfitting. We are going to underfitting. If we are increase the depth, then we are going to overfitting. The same things also applicable for regression. Just see this thing. Okay, so this is our sample, this is our original regression line, but if we take when depth is equals to 2, then we will see, they just see the red line, just see how behave like. how the decision tree behave. Just think this thing, just like this one actually look like actual. If we take on the depth is equals to 2, just this thing, black color line, a red color line is the depth. Actually here we are not considering so much point, just we are neglecting this point, this point, this point, this point, this point. We are avoid this point, neglect this point. Means this, in these situations, our model is what? Our model is here underfit. This model is actual underfit model. If we just increase the value of, if we just increase the value of just see this line. If we increase the value of, suppose I am taking here depth is equals to 5. Okay, just see this line, just see this line, green line, just simple see the green line. Here I am considering all the point, as well as here this thing, this kind point as noise point. Actually, if you just see this thing, actually this is a outlier point, noise point, this point. If we increase the depth of the tree, then our decision tree considered this outlier point. Okay, this is the some kind of look like, but actual if when we learn the, if you see, when we learn the random forest, when we learn the gradient boost decision tree, then in this extension of the decision tree, yeah, easily take the regressions, easily you can sometimes we can track the regressions line. But the original, the simple decision tree concept are so much failure to for a regressions problem, for a regression problem. So for a regressions problem, we always prefer random forest, yeah, gradient boost. We will see this thing in a next series of lectures. Okay, just see that I am giving the just give the flavor of this, how actually decision tree works in regressions, as like that. If we just increase the depth, then we are going to here overfit. We have considering the overfit model, means here we are considering our noise data as well. But if we just neglect decrease the depth of the tree, means here if we just decrease, I'm taken here the value depth of the tree is 2, then you can see the red line. We are neglect so much point. This point we have neglect, this point we have neglect, this point we have neglect, we have not considering in our calculations. So this is simply we have taken the bias here so much. But if we just simple, just I am increase the small value of the depth. Okay, just I am increase the 2 to 5, then how much, then this our model is consider this outlier point, this outlier point. Okay, this is the actual look like regression model for a decision tree. I think you got the flavor of the decision tree for regressions, how it actually works.